Have you ever just stopped and thought about all the hidden science that's packed into your daily routine? I mean, seriously, from the tea you brew in the morning to the rice you cook for dinner, we're separating things all the time, and we probably don't even notice. So let's dive in and uncover the brilliant science behind something that feels so simple, a skill we use constantly, pretty much without a second thought.
So let's meet Mully and his sister Vali. They're on summer vacation, visiting their grandmother's house. And the very first thing they see when they arrive is the whole family out in the courtyard, super busy, sorting through these huge piles of grain. And it's their curiosity about this everyday chore that's going to kick off our whole journey of discovery.
And this really gets you thinking, right? It brings us to the big question here. Why is this so important? Why do we even need to separate substances in the first place? It seems like a ton of work, but as we're about to find out, it's absolutely essential.
Well, it really just boils down to two main reasons. First, you've got to remove stuff that's useless or maybe even harmful, like finding tiny little stones in a bag of rice. And second, sometimes you need to isolate one really useful component from everything else, like getting pure salt from seawater. It's all about purification and isolation.
Okay, so let's start with a scene I think we've all been in. It's lunchtime, and Molly is carefully picking every single black pepper out of his pulao. His sister's teasing him, of course, but what he's actually doing, whether he knows it or not, is using our very first scientific method of separation.
And that method, it's called handpicking. It's exactly what it sounds like. It's the most basic way to separate things, where you physically pick out the unwanted stuff from a mixture with your hands. It's as direct as it gets, and honestly, it's surprisingly effective.
So the whole idea behind handpicking is that we're really good at spotting differences. It works like a charm when the things you want to get rid of have a different size or color or shape. It's absolutely perfect for small amounts, like cleaning a bowl of rice before you cook it, or, like Molly, just making your lunch perfect. Okay, so let's zoom out. We're going to go from the dinner table all the way out to the fields and see how these same ideas get a whole lot bigger. Because in farming, you're not just separating one plate of food. The basic ideas are the same, but the methods have to be scaled way, way up for the entire harvest. And this is what Molly and Vali see next. Farmers out in the field taking these big bundles of wheat stalks and just beating them against a wooden log. Now, it looks like incredibly hard work, and it is, but there's a really specific reason for it. They're literally knocking the valuable grains loose from the stalks. This process has a name, and it's called threshing. It's the first big step you take after you harvest a crop, and it's all about breaking those grains free from the rest of the plant. The whole goal is to separate the part you can eat from the part you can't. And what's so cool is seeing how technology has totally changed this process. Traditionally, it was done by hand with pure muscle power, but now we have these huge modern threshing machines that do the exact same job, just 1,000 times faster. It's the same principle, using force, just applied in a much more powerful way.
So after threshing, you're left with this mix of heavy grains and really light, flaky bits called husks.
This super clever method is called winnowing, and it uses a really simple principle of physics. The wind is strong enough to carry away the lighter particles, like the husk, but the heavier, more valuable grains, they're not affected as much, so they fall straight down. It's such an elegant and efficient way to use a natural force to get a job done.
The poet Kabir actually wrote this beautiful metaphor about it. He said, just like winnowing makes the husk blow away while retaining the greens, similarly, sages let the virtues stay while discarding the vices. What a powerful idea, right? Connecting this simple farm task to a much deeper philosophy about holding on to what's good and letting go of the rest.
All right, let's head back inside and into the kitchen, which, if you think about it, is kind of like your own personal science lab. Separation is happening in here all the time, especially when you're baking or cooking. I'm sure this is a familiar sight for anyone who's ever baked a cake. When you sift flour, you're doing more than just making it light and fluffy. You're actually performing a really important separation, getting rid of any lumps or coarse bits so you're left with just the fine flour you want. And this, of course, is known as sieving. The secret here is all about particle size. A sieve is basically just a screen with a bunch of tiny, uniform holes. Anything smaller than the holes gets to pass through, but anything bigger gets left behind. It's a brilliantly simple way to sort solids based on how big they are. Okay, but what about separating solids from liquids? I mean, everything we've looked at so far has been about separating one solid from another. So how do we handle something like muddy water
Or maybe more deliciously, tea leaves floating in a cup of hot water?
Well, for this, there's a really neat two-step process. The first step is called sedimentation. You basically just let the mixture sit still and let gravity do all the work. The heavier bits that won't dissolve, like sand or tea leaves, will slowly settle at the bottom. Then comes step 2, decantation. That's when you carefully pour off the clear liquid from the top, leaving all that settled stuff behind.
Now let's shift our scale one more time. We're going from a teacup all the way to the ocean itself. How in the world do we get something that's completely dissolved in a liquid, like salt in seawater, back out again? This is actually one of the oldest and most important industrial separation methods in human history, and it's powered entirely by the sun.
And here's how it's done. Seawater is collected in these huge, shallow pools called salt pans. Then you just wait. Over time, the sun's heat works its magic, turning the water into water vapor, which just disappears into the air, but the salt that was dissolved in it, it has nowhere to go, so it gets left behind, forming those familiar salt crystals.
This process is, of course, called evaporation, the transformation of a liquid into a gas. And it is the perfect method when you have a solid dissolved in a liquid, because the liquid part just vanishes, leaving the valuable solid all by itself. Pretty cool, huh? So, wow. From the dinner table, to the farm, to the seashore, we've basically just built an entire toolkit of separation methods. Let's do a quick run-through of all the awesome tools we've just collected. Okay, so here's our toolkit. We started with handpicking, just using our eyes and hands. Then we saw threshing, which uses brute force to break things apart. We learned how to harness the wind with winnowing and the sun with evaporation. We used simple tools like sieves to sort by size, and even used gravity itself for sedimentation. Each and every one is a simple but totally brilliant solution to a common problem. So, the next time you make a cup of coffee or strain pasta for dinner, or even just watch dust settling on a shelf, you'll know the science that's happening right in front of you. Now that you have this toolkit, my question for you is this: what other bits of hidden science are you going to spot in your life today? Keep your eyes open, you'll be surprised what you find.